This is an extra lesson I put in on bearings that someone asked me to do some work on. So year 10, if you get a notification of this one, don't worry about it. It's not on the Moodle work I've put on the school website. This is just an extra one for someone else who's looking at stuff we're doing, and if you do want to go back and use it as revision, it is useful. It's going to go down as lesson 7 because it was in chapter 3 section 1. Also comes up in chapter 7, working in 2D when you're doing diagrams. Comes up later again in further Pythagoras right near the end of the book. So it is a useful topic to know. Comes up in a few areas. So this is all about bearings and looking at the facts related to those. Added a new feature in now. You can see my head in the bottom corner, which might make it nice that it's not just a disembodied voice. Talking over a PowerPoint, you can see it is actually me. The big advantage is it allows me to write on these PowerPoints. So first of all, we need to think about useful angle facts to remember, and you should know that a full circle is 360. It's really important for bearings. Also straight lines 180 and right angles 90. Not so useful in bearings, but always a good one to remember. So there's two examples of bearings, and this one over here just gives you a sort of map. The idea of a bearing, as it says at the bottom, is you always take north. So you use your compass on a map, get north pointing straight up, and the bearing measures clockwise going around from north. So that can be anywhere between 0, which would be north, all the way around to 359, which would be virtually north again. Obviously, if it was 180, that would be a half turn going straight down, and that would be called due south. Another thing that does come up is this idea of back bearings. So this is where it links into angles, because if you look here, that looks a bit like those F angles corresponding, or you could think about Z angles, the alternate ones that we've seen before, and also sometimes something called co-interior, which we'll look at in a little bit later on. At the very bottom of the PowerPoint you can see something where we mentioned 3 figure bearings. 3 figure bearing is what it says, it's 3 figures. So instead of writing 30, we write 030. Obviously if the bearing is this one, 100, 210, we would just write it as 210 because that is 1, 2, 3 figures. So as I said, we need to remember those alternate angles, in particular Z angles. They're useful for working out things called back bearings, and also this idea of co-interior. So this is where the pen comes in handy, because I can show you that if we use the F angle rule, that's 39, then this is going to be 39 as well. Then we've got this straight line going through here, so if that's 39, and then we've got an angle here, 39 and 141 make that 180. Obviously the way you'd work it out, if you know that's 39, you know this is 39, so you do 180, take away 39 to give you that 141, and that'll be useful, as I say, in back bearings. Okay, so now we're going to do some examples, and some of you will be familiar with the fact I'll show you the question and then we'll actually do those on paper and I'll show you the working out. So you might want to take a screen print of this, print it off so you can look at what I'm talking about, but I'll be doing this on paper and showing you how you can get these. Actually, given that I've got the pen tool, I can use the pen just to go through on this. So we want the bearing of each port from the capital. There's capital C, and if we want the bearing of L, there's my north, so the bearing to L is this 31. If I want the bearing of P, P is all the way around here, so I need this whole angle to get to P. So what I can see from that angle there, that's 78, I'm going to have to use what we call a back bearing. So if I draw a Z on there, that's 78, that is 78. So all the way around is 360. If I know from my Z angle that that's 78, so that is 78, I can do 360, take away 78, which in my head comes out to be 282. You can check that on a calculator because I'm just working it out in my head. So that's with this idea of a back bearing, using that idea of Z angles, and sometimes you might need co-interior, but we'll look at that maybe later in some of the questions. We've then got this C1. Well, I've worked out already that that is 78. I know from the diagram this is 42, so 78 and 42 in total make 120. So that whole angle there is 120. So this time I've got to do the 360, take away the 120 to give the bearing of that one as 240. Find the bearing of the capital from each port. So each one of these is a back bearing, in fact, because they're going back to the capital. But this one's okay because I've got that angle there. So if this is 180, then 180 take away 78, it's going to be 102 for that angle there. So my bearing, north is straight up, I've got 102 there for my bearing going to the capital. When you're measuring the bearing, you always have your north at the point that you're going from. So I'm going from P, so that's where I draw my north line. If I'm working out the bearing from L to C, I'm putting my north line there, so I need the angle all the way around to there. If we look at this one, we're going to have to again do a little bit of back bearing work. So if that's 31, I'm going to say that that is 31 as well, because I've got an F angle on those two there. But that's not going to help me on this one. What I need to work out really is that missing angle there. So that is where I'm going to bring in a Z angle there. That's 31 using my Z angle rule. That angle there is 31. So the angle all the way around is 180 to get to the straight line, and I've got an extra 31 from that Z angle that I can see there. So 180 and 31, that bearing is going to be 211. Finally, I want my bearing from Y. So my north should go straight there because I'm measuring this angle. This one here, I've got to work out that bearing there. Quite a complex one, because I've got my north straight up there. I need to go back to an earlier fact that I worked out that this angle was 42 and 78. So that angle there all the way around was 120. And that's the one that allows me to work out the bearing from there down to there is 120. These ones I will need to do on paper, so I'll read out the question as we go through them and I'll show you my working out on paper. Always useful with these bearing ones to actually draw the diagram. Often in the exam the diagram will be there, but we've got the radar station R, and this is due west of another radar station est. So R is due west of S, and I'll put north in at both of those. Due west is going that way. R is due west of S. If we said that S was due west of R, S would be over here. But we've got R is due west of S. The bearing of the plane P from R is 162. So from 162, I'm going to guess that's sort of around about there, and this is my bearing from R, 162. The bearing of P from S is 205. So 205 is going to be round about down there. So it's purely going to be a case of where these two cross. That is where P is. And this is a thing called triangulation that is used in navigation. On which bearing should the plane travel to go to S followed by R? Again, a little bit of idea of back bearings. Obviously it's going to be useful to have my 180 there, and I think it's quite useful to have the separate bit, the 25 there, which makes my total of 205. Because if I want to go from S and then R, I've got to go from here up to there. So my bearing to go there is going to be 25 because I've got an angle of 25 there, and I can use the Z rule to get that to be 25 as well. So my bearing from P to S is going to be a bearing of 25 to get me to there. If it then wants to go from S to R, that's going to be purely that bearing all the way around there, which is 270. So 90 degrees taken away from the 360. Just got a slightly clearer picture there to show that Z angle I used. We knew that that was 205, so this bit's 25. Using the Z rule, that's 25, that's 25. So this is the diagram I've got for question 6. The boat has sailed northeast from port P. Northeast is going this way. North is straight up and east is there, so northeast is there. We've got a bearing of 45 degrees. Goes up to this buoy B, and it sails on a bearing of 298. So all the way around to there is 298. Straight down, that's 180, so it leaves me 118 to get up to there, which will be useful for answering the question, knowing that. The question says, find the bearing on which the boat needs to travel to return directly from L to P. Well, that's reasonably simple. If it's up here, due north, to go back straight down to P, it's going to have to go due south, which is 180. To retrace its journey from L to B and then P. So this time, it's going to do that back bearing idea. So we knew that from earlier, this angle down here was 118. From that, I can calculate that the angle left up here to make the whole of this 180 is going to be 62. If that is 62, using the Z angle rule, I know that that is 62. So that's going to mean that this angle here, the bearing going down, is 118. Again, if you can use co-interior, you can get those straight away. But this is just going through the steps to actually prove what co-interior is. But the bearing to go from L back to B is that 118. And finally, we then need to go from B back to the port we started in, P. So we're going to want this bearing going back to this one. So I just want to make this line clearer. If this is 45, again I've got that Z angle, so that one in there is 45. So the bearing to go back is going to be 180, add that 45, which gives me an answer of 225. Okay, some quite intricate use of Z angles, but as I say, if you can look up co-interior, sometimes that does speed it up, but the F and the Z is enough using that corresponding and alternate. Take care, bye bye.